I'm waiting for Angelique making the picture, because I'm always speaking. All right. It's not working, right?
Is it working?
That microphone is just for the stream.
Okay.
Ah, okay, cool. Fine.
So just speak up.
Amazing. Yeah. So, welcome to our session, Implementing Event Sourcing Strategy on Azure. My name is Olena Borzenko, Elder Grotemur, my friend, mentor. Before we will start going into details of the session, we want to say thanks to our sponsors, of course, because without our sponsors, we would not be able to be here today and have sessions, networking, and amazing time. So, thanks to our sponsors. Wait, I will wait until everyone will come in.
Yeah, there's no response slide.
Yeah. Yes, so we have more sponsors, once again. And we will keep moving. So, first of all, who are we? I'm originally from Ukraine. I currently live in Germany, and I'm working as a celestial programmer, actually in a consultancy company called Spirit. Eldad?
Yeah, so I'm Eld Grotemur. I call a company you might have heard of, Microsoft. So I work as a program manager on Service Bus. So basically that means I do everything that I need to do to make Service Bus a success and make sure that everyone that's using Service Bus can actually use it and has a good experience with that. So I'm from the Netherlands, but I joined Microsoft in February, and then we also moved to Canada. So if you want to reach out to us, we're on Twitter, so please reach out there.
Yeah, true. A couple of words about the session itself. Why event sourcing, why Azure? So first of all, when I was working in a product company, we decided to try out Azure Cosmos DB. And with Eldad, because he's my mentor in the community, we were discussing quite a lot of topics, like what is popular now, what makes sense, what is good for building systems, and so on, so on, so on. So Azure Cosmos DB has a change feed, which is kind of event sourcing out of the box. So we decided to try out to build a session around actually implementing the full event sourcing, not just using the feature from Azure Cosmos DB, but also like amplifying the functionality with another Azure services integrated all together.
But before we go into that, let's first have a quick look like what is event sourcing. So this is on the page from Microsoft in the documentation. And so basically event sourcing, you could get events in. And so each event you store into an event store. And that event store you then use to hook up to your applications. And you can do this through Materialized Views, which we will see a lot more on later, where you basically just create a projection of your orders in this case, or whatever your entity is. You create a projection and you show that to the client. You can also hook up the clients directly, so the clients can actually come in, play those events back, and get the updated projection. Or you can just query over all those entities and just get the latest state that way. So event sourcing is really about those events coming in, and then using those events to replay them and creating that projection of your entity in the way that you want to. So why should we use event sourcing? First of all, let's have a look at CRUD. So I think everyone here at some point created a CRUD application. So you create something in the database, you can read from that, you can update it in the database, you can delete it at some point. But you're working with the same entity in the database, it's just one record, and you keep updating that as you continue working on that entity. The downside of this is that if you are using heavy write-load applications, you'll run into locking. Because you can only have one application, one writer that's working on that record, because otherwise your entity will get in a state that you don't want to be in. So you have to lock the data, and then every time that someone is operating on that same row, on the same entity, you have to unlock it, update it, and then the next producer can come in. So this is not easily scalable. Of course, you can scale databases quite far, but at some point you will hit into these restrictions, especially when you talk about millions of producers. You will start running into these issues where you might run into deadlocks, or just in very slow applications because they all try to update that same record. And also you don't have any history. Of course you can build your own history table. You can just say, okay, whenever I do an update, I will write this to a log table that I did update this and with changes. But it's something that you have to build yourself. So this is why event sourcing comes in, because it basically solves these problems. So event sourcing is you don't update the objects, you just do inserts. So because you don't update, you also don't have those locking issues and all that kind of stuff. So this is really good for those write-heavy workloads. If you have millions of producers, this is perfect for this. Because you are only doing inserts. As long as your data store can handle those inserts, you're fine. Because inserts are, of course, much more efficient, because you're not locking anything. Anyone can just push those inserts in. And like I said, what we see today, like Cosmos DB can handle like millions of inserts per second. And that's what you want in these cases. And what's also very nice about event sourcing is that you have that built-in auto log. Because you just have your event store, and that's basically your log. Because it just shows you all the different things that happen to your object. Because just all an event, like I created an object, I updated it, I did another update, I added something. It's all just events, and by playing them back, you'll get the current state of your entity.
Okay, so there was the slide, the previous slide when you were mentioning scalability problems.
Yes.
What about event sourcing?
Yeah, so event sourcing, because you only do inserts, is much more scalable. Like I said, as long as your data store, in our case it will be Cosmos DB, but of course you can also use different data stores. But as long as your data store can handle those inserts, you can scale up indefinitely, basically. Because you don't have locking or anything like that. So as long as you can do inserts, you're okay. So that's why this is so much more scalable, and also why we see this pattern like in those very high producer workloads. So let's have a look at event sourcing on Azure. So we are going to discuss 5 different services, and the first service Olena is going to talk about, which will be Cosmos DB.
Yeah, so Cosmos DB, I already mentioned that there is a change feed, which is an amazing feature that provides us history of our data. It provides us event sourcing out of the box, a lot of possibilities for testing, for example. We can do smoke testing, we can build new materialized views or like snapshots for new clients if you need, because we have all the data always stored there. And if someone, give me a click. If someone didn't use Cosmos DB before, I just want to say a couple of words about what it is actually, what kind of features there are. So it's a massively scalable, globally distributed document database. It's like main words. So there is 5 different APIs. I think maybe they added something new. No. There is a table API, there is SQL, Cassandra, MongoDB, and Gremlin. So by default, when you create Azure Cosmos DB, there's going to be an SQL API. And who used SQL before? Like everyone. Yeah, cool. So this is very, very confusing, because I did a mistake when I started to work in with Cosmos DB. I didn't really have experience with cloud, serverless, or anything, or a document database, so I didn't know how to design my data. So I started to just do the same thing as I do with SQL, with relational databases, because there is SQL API. I saw that there's somehow transformation is happening, and like it's gonna work fine. It's ended up in a really expensive queries, expensive reads, expensive writes, like because of the how database is actually built, because of the partitioning that we have physical and partitions that are actually servers where we are storing our data. And the data can be distributed between those servers. So when we actually just use query, there is no guarantee that our data will be called from the same physical machine. That's why it's kind of ending up in a bigger cost. So don't use it with like a normal SQL relational databases. But with the rest, if you have Cassandra or Mongo or whatever, you can easily just switch. And in theory, it should work. And I know the cases where like successful cases, but I also know the stories when something failed, but it's like edge cases. So normally everything is all right. There is also 5 different levels of consistency, starting from strong to eventual. We will not talk about it that much because yeah, we will run out of time. So moving a bit forward, the next service we will use is Event Hub.
So next one will be Event Hubs. So Cosmos DB will be our data store. So this is where we are storing those events. But we don't want to expose the Cosmos DB directly to our clients because you don't expose your data store directly. So what we need is some kind of ingestion mechanism for those events. And this is where Event Hubs comes in. So Event Hubs is basically a stream of data that you can push in. And it uses a client-side cursor. So for those that are familiar with Kafka, will probably know this, like you can just move your cursor backwards. You can start reading whatever you want in that stream. Unlike Kafka, we don't store the data indefinitely. We store it for 7 days because we think that this should not be your data store. It should be your ingestion mechanism. So if you're coming from Kafka, this will be a bit different, but basically it's just an ingestion mechanism. You can read that data, push it into something somewhere else, where we are going to use Cosmos DB for this. But it's actually like very similar to Kafka. We also have a Kafka compatible endpoint. So if you are using Kafka, and I will show this in the demo, if you're using Kafka already, you can just change your connection string and it will just work. The next service will be Event Grid. And Event Grid is also about events. But where Event Hubs is about the stream of events, Event Grid is about discrete events. And discrete event is basically saying, hey, something happened. Someone might be interested in this. I don't know who's interested, but if anyone is interested, here's some information about what happened and where you can find that data or something like that. And Event Grid is also like Event Hubs, also Event Grid is also very highly scalable. Both of these can handle millions of messages per second. So if you, of course, you have to scale up for it. Like if you do millions of messages per second, you will be paying for it, but you probably have the use case where you want to pay for this. So an Event Grid will just is a push-push model. So where Event Hubs, you push it in and then your consumer comes and get it. Event Grid is push-push. So push it in and Event Grid pushes it out to the clients. And you can have 0 to multiple subscribers on this, and it will just distribute this. You can set up some rules like for routing, where you can say only route to this endpoint if the path ends with something or starts with something. And this is very nice because you can, for example, say, well, I have orders, I have invoices, I have all different kind of entities, and then you can route those to different systems. And the third messaging service is Service Bus. And of course, I'm the program manager for Service Bus, so of course Service Bus had to be in here.
We need all of them.
Now, but so Service Bus is really nice because it has, once again, that push-pull model. And so what you will do is you put a message, so not an event, but a message. You put it into Service Bus. And the difference between an event and a message is an event is something happened. It's basically a fact. So it might be like, okay, this event happened, or hey, the blob was created, or something like that. A message is actually something that you care about. A message, for example, is this is my order. This is my invoice. It actually has data in there, and it's also valuable.
What is happening?
There we go. But it's valuable. So you want to make sure that your message gets delivered. So what we do in Service Bus, we guarantee that once your message is in Service Bus, it will stay there. And we'll only remove it if you say we can remove it. So you push it in, you get an acknowledgement back. When you have that acknowledgement, it's in there. We will store it, it will be safe. Then the receiver can call receive. And we basically have two kind of receive modes. We have receive and delete, which is just, okay, give it to me and then you can delete it right away, which is at most once delivery. But we also have at least once delivery, where you can say, okay, I want to receive it, but I will lock it and I will call complete when I'm done with it. And as long as you don't get it complete, it will stay on the Service Bus. So only you will be in charge of saying, okay, I now actually process this message, you can now delete it. And so if something happens in the client or your connection breaks or whatever, it will still be there. The client can come back again saying, hey, okay, I did not process this, please give the message again, and only when you complete it, it will be gone. And finally, we also have to do some processing, and that is where Olena will talk about.
A lot of information. Yeah, Azure Functions, just a tiny bit speed up here. So we will use Azure Functions because we don't want to take care of anything like deployment, all this like stuff. We want to make it as easy as possible. So serverless, it's for us is with integration with Cosmos DB and the connection to change feed. So we can easily react on updates, on writes, and we can create materialized views for read operations. So that's why we decided to go with Azure Functions, and also that we can have small pieces, small blocks of our business logic, and it can be independently developed and, well, easily scalable. So.
Yes. Okay, so with that, let's actually go to a demo. And what I'm going to show is that we will have a Kafka application. So it's written in .NET, but could also be written in other language. But the thing here is you just change your connection string to Event Hubs connection string, and it will just work. So that Kafka application will then go out, I think you, there we go. Yeah, there we go. So it will push this out to Event Hubs, and then Event Hub will be that ingestion there. So we a stream of events that we get in, and we then will start processing this. So we will use a function that will listen to this Event Hub, and that function will then, in our case, just push this out to our Cosmos DB, but of course, this is also where you can push your business logic in. Actually, we have a little bit of business logic here, because we're actually going to check for the status. So we are going to create an order, and that order will get some updates, and at some point it will be delivered. And at that point, something else will happen, which I will talk about more later. But what we will first do is just store every event into Cosmos DB. So this will be our event store. So all those events are just stored in Cosmos DB. But like I said, oh, and of course our clients can then read from that Cosmos DB and do their own transformations on this, get their own projections. But like I said, we're also going to do a little bit of business logic in here. So we're going to check if this message is delivered. So if the order is delivered, we are going to raise an event. Because at that point, we might, for example, say, hey, the order has been delivered. We now need to send out the invoice, or we might have some other system that needs to start doing some work. So we're going to create an event saying, hey, this message, this order was delivered. It will only contain the order number and saying, hey, this was delivered. So it will be a very small event. And we'll push that out to Event Grid. Event Grid will then route this to its subscribers. And one of those subscribers will be a function. And what this function will do, it will go out to our Cosmos DB, get all that information from the order, and create a message out of this. So we'll have all the order information in there, like the time of delivery, or the items in there. All that information will be in there. And then we'll push that message into Service Bus. And so then our message is in Service Bus, and then our clients can, of course, come over here and start collecting those messages. So this might, for example, be our invoice system or whatever. And like I said, a message is important. So for example, an invoice, you want to make sure that invoice goes out. So you need something that is making sure that you can actually get that message to that system. So let's have a look what this looks like. And we start over here. So this is my producer. So as you can see, it's the Kafka producer. I'm just using the Confluent. Oh, wait, sorry. There we go. Yeah, now it should work. So this is just a Kafka application.
Maybe zoom in.
I can. There we go. And I'm just using Confluent Kafka libraries here. So this is just like any other Kafka. It's used the Confluent libraries, so it's perfect Kafka. And so the only thing I did is change the connection string to my Event Hubs connection string. And what this producer will do, it will create some messages. So in this case, we'll create 1,000 orders. And for each order, and I'm not going to go into much details on the code is on GitHub if you want to have a look at this. But what I do want to show is that we will create an order. As you can see, we do use some random data for this. So we'll create an order. It will add some articles. Then it will be sent to Event Hubs. Then next event will be an order has been accepted. You have the articles updated, order cancelled. So this might happen, though it won't always happen. The order will be getting picked, out for delivery, and finally delivered. So in this case, I just have one system that does all of this. Of course, in real life, this would be multiple systems that are creating those events. They might even have their own data format and stuff like that. But for our demo purposes, we just use one application that will produce all these events. So let's start this, and this will now start sending those messages to our Event Hubs, where we then are going to pick this up. So while this is starting, let me go to the function, because like I said, it gets pushed into Event Hubs, and then we'll have a function that reads from that. As you can see, it's now starting to send. So we have our Event Hubs processor over here. And in this case, I'm using a Cosmos client, so I'm not using the binding. So like Olena mentioned, you can use bindings for different applications. In this case, for Cosmos DB, I'm using client, so I'm just using SDK. And that is because I want to have some more control over our Cosmos DB. So for example, I want to filter out some empty fields and stuff like that. And there's some different ways you can do this. In this case, I'm just using client, Cosmos DB client. You could also write your own custom binding, where you actually implement this yourself. Or if you just need like the standard functionality, you can actually use this trigger over here. So if I just use this trigger, it will just use the out-of-the-box binding. But like I said, you don't have as much control when you use the SDK. What I do use the binding for is Event Hubs. So for Event Hubs, I just want to say every time a message gets into Event Hub, pick that message up and process it. And so as you can see, the only thing I have to do is say, okay, this is my Event Hubs database or my stream that I want to read from. Here's my connection string, and that's it. I don't need to know how to implement Event Hubs processing or anything like that. All the checkpointing is managed for me, like everything is managed, and I just will get a stream of events that I can then look through. And I will push this out to Event Grid. So this is my input binding, and I over here have an output binding. And so for Event Grid, same kind of ID, I just point to my connection string and my key, and that's all I need to know. So I don't need to know how I'm going to create this connection, how I'm going to create all the things. That's all managed for me. So this makes it very easy for me to actually just get some data in and push it out again. So like I said, I'm going to do some things with Cosmos DB, so like ignoring some empty values. But what's important is over here, this one. So whenever our order status is delivered, it will create an event. And in this case, like I said, it's a very small event. It will just have the order number and status delivered. So I will send that to Event Grid, and of course, all the other items are just being pushed into Cosmos DB. So that whenever an event comes in, it will be pushed in Cosmos DB into our event store. Let's see. What was next? So yeah, let's go to Cosmos DB first, just to show you. So I have my event hubs running over here. There will be some load over here. I have my function that's processing this. So as you can see, there's some execution going on. And this will then be pushed into Cosmos DB. So if I go to Cosmos DB, let me zoom in a bit. Oh, not that one. So if I go to my Data Explorer, one second. Yeah, there we go. So I can go to my orders over here. And if I look at the items in orders, there should be a bunch of items in there that I just pushed in. So let's just select one, and as you will see, there's like the order number, order status, the hub ID, so basically the warehouse where this is being delivered from, the customer, some information about where are we going to deliver this, some information about articles, and then if I, let me check if I can find something very quickly. No, these will all be requested. So, but basically there will be multiple events like with delivery status of like picking and stuff like that. There will be events that have information about when was this out for delivery. So we have all these different events. They all like look kind of similar, but like there will be different information in there. Now, like I said, at some point we are going to get that delivered status. So we are going to send out an event, and that event will be sent to Event Grid. And here in my Event Grid, I will have two subscriptions. So I have this Event Grid processor, which is my Azure function. So that will trigger another function. And I have this webhook site over here. And this just to quickly show you what those events look like. So let's see if it wants to load. And this is just like for debugging. This is a very nice site. It will just show you all the events that are coming in this case. And just to show you what an event looks like I said, it's very small. There's some information in here from the Event Grid standard itself. So Event Grid itself expects some data, not data, the subject, the ID, data version. So there's some information that Event Grid needs. And our own custom data, which in this case is just the order. As you will see over here, I have this delivered event type, and I have my order ID over here. And that's all I need to send out, because every application will maybe need different data, so I'm not going to push any data in here. I'm just going to say, hey, if you're interested, this is the order number, and this order was delivered. So I could, of course, also have different events. In this case, you just have delivered status, and that will be sent to that function. So like I said, I have another function over here, my Event Grid processor. Once again, I'm using the Cosmos client to get that information out. In this case, I'm using Event Grid trigger. So this will trigger whenever an event comes in on the Event Grid. It will trigger this and we'll get that data from that event. And I have the source bus out binding. So this will just create the source bus message and push it out to source bus. Now what I'm going to do here, I'm going to query on my Cosmos DB. So I'm going to get where my order number is, this specific order number. I'm going to get all the data back. I'm going to check, look through the results, so that I will get like 5 or 6 events. I'm going to look through these events. I'm going to create an order, so this will be like my message that I'm going to create. And then I'm going to update order with different things. So, so if the order was for picking, I will update the delivery part. If the event was about delivering, I will update the picking date and planned delivery time. So I'm just going to take all those different pieces from those different events and create one message out of this. And finally, I will send this out to Service Bus as a JSON message. So if I go to Service Bus over here, and for those that work with Service Bus, you probably know that there's the Service Bus Explorer, the open source tool. What we actually did, previously we already had the Service Bus Explorer in the portal, but it was very basic. What we heard is that a lot of our customers actually want to have that functionality from the standalone open source Service Bus Explorer in the portal. So we built that. So we have this Service Bus Explorer over here, and basically what we did is just take like the most requested features first, and we're going to build up on top of this. So if you want to see anything here, let me know, and I will make sure it gets on the backlog, and hopefully at some point we can implement that. Yeah, what we can do here is we can peek those messages, and peeking is just saying, okay, show me the messages, don't do anything with them, just show me, in this case, the first 100 messages. And if you go look at the message, what we'll see down here is, this is my message over here. So I have my order number, my order status, information about the customer, information about the delivery, the articles that were there, and then you just have all the information here now. So this is just your message, and like I said, this might now be an ordering, like an invoicing system, that picks up this message, and for example, creates an invoice out of this, or something like that. So with that, let's go back over here. And there we go.
Did you press from the start?
No, I didn't. And Olena is going to talk a bit more about Materialized Views.
Yeah. Yeah.
Okay.
All right, so Materialized Views. What is this? Why do we want to use it? We saw already how we can write data, Service Bus, Event Hubs, even grids, like how we can get all the data done, get all updates all right. So what we can do to enable read operations, but read operations for every client, for every consumer, there has to be different like data, like scheme or interface. They have their own requirements, different fields, different objects, and also new clients will be added. That's why we want to use Materialized Views, that we will be able to cover different use cases, not just new clients, and we will have the same source of data from which we generate those snapshots. And we will be able to react on every change, on every update or write operation that is happening, update our Materialized View, and populate this data, like make it available for our clients. So once again, this is more efficient querying, basically. This is what we're enabling with creating the snapshots or Materialized Views. We are making pre-calculated queries, saving them in database or like in our different containers, and then we just make read operations. And it's gonna save us a lot of cost, and as I mentioned already before, we will be able to react instantly, almost instantly, on every change. And for this, we will use Cosmos DB change feed. So change feed is, Cosmos DB change feed is event sourcing out of the box, as I said before. It's going to store all the data, not just changes that happened in between like one state and another, but the whole document. And we will be able to access this data anytime, from any point of time. And we will generate from all the documents which we have in the change feed, we will either pull them or we will just subscribe on a specific container, and those notifications will be events pushed to us, and we will aggregate the data and build the views. So basically, that's how it looks like if we have our order data, and we have different applications. We have client, web client, we have mobile application, maybe some tablets, doesn't matter. We write our data. In the change feed, we store, there is a whole history is getting stored. We also have our containers with our data if we need it. I mean, with all the information about orders, articles, and products. And we create the materialized views, making available to see the aggregation.
Before you continue, so what you're saying is you're going to duplicate the data in different ways. Like anyone that used to work with databases, we always heard like you normalize your data, you don't store something twice. So why is that different from what we are doing now?
Well, I'm not really duplicating the same data. So I'm going to generate different views of the same data. So maybe one customer wants to see the order details, another customer wants to see all the products that were delivered. For the warehouse system, another information might be valid, but it's based on the same set of data. So not duplicating, but transformation, pre-saving, pre-calculating, and making it for easy available for reads. So our reads are cheaper, our write operations is more expensive, and this will save us a lot on the cost.
You've got one slide.
Oh,
Come back.
oh yes, sorry. This is how our system looked like before. If anyone saw our session earlier, what we were doing basically after receiving all those events, Azure functions, writing back to Cosmos DB, then again reacting on those updates and creating materialized views, writing them back to Cosmos DB. So that's how we were doing it before. But this is not a right way to do it. So basically, in the Cosmos DB, we are storing history of our data. We should not take this data. We should not try to build any business logic on it. So instead, Eldad already was talking about another way, how we decided to do basically the same thing. The result will be the same. We will have different materialized views for different clients, different use cases, but we would not react directly, just have some triggers on every change and write it back to Cosmos DB. We will have events, we will have messages. Do you want to add something?
No, that was perfect described, yeah. But like I said, it's more about the Cosmos DB is more like the operation in the data log, where in a discrete event is something that you actually want to trigger off on a certain point. So that's why we made this change where you say, okay, we have this upper path now, which that's discrete events, and then the lower path that Olena is going to describe now.
Yeah, the other path is on top we had update of our orders. So basically the whole flow, how our orders created, picked, and delivered, everything. So then afterwards, we want to have some more information. I want to enable for our customers to see what they do, like history, products, like on Amazon we have what we already had delivered or not. Or for our warehouses, for example. Maybe we have a support team when there's incident happen and they need certain set of data to react efficiently. So we will do it in this flow. We will have Azure function. We will subscribe to a container where we'll have those updates, like something has happened with the order, I don't know, it was delivered, for example. We will react on those changes, and we will update materialized view we have, and we will write back to Cosmos. Yep.
You have to do your demo.
Oh, where's the demo slide?
Yeah.
All right. That's just demo time. There was supposed to be separate slide, demo time.
It was there. Look,
yeah,
demo
but
time.
it was different before.
No worries.
Can you tell me that?
That one.
This one.
That
Yeah, yeah, yeah. What should I press, you said? Escape. Okay.
On the
It's blacked out, yeah?
this one.
Yeah, yeah. I use Mac. I don't use Slack.
Wait, that's the wrong one.
Yes, that's the wrong one. Yep.
There we go.
All right. I didn't say much about change feed processor, a change feed in general, because I want to, while showing, I will explain a couple of things about how we can interact with this, how we can get our data in different ways. So first of all, if everyone can see everything. Yeah, that should be fine. So I have a couple of projects in my solution. Again, it's all in one place just to make it easier for the demo session. But I just have the base repository, customer repository, so how I'm going to interact with my Cosmos DB. I would also not spend too much time on going through the code. I'll just go through the components we have and how they basically depend and interact with each other. So the base repository just describes how we, what kind of operations we're going to do on Azure Cosmos DB. So we're going to read documents, we're going to create documents, and we're going to update existing document. This is very simple business, like there is no business logic basically. There's very simple logic, just having a partition key and having the ID of a document. Ideal case when they are the same and they are unique, both of them, it means that we can access document, have a point read operation. It's the most the cheapest operation you can have, and then we're just gonna replace or create the, not create, but read the document. We have a customer repository and also warehouse repository, which is just shows to what exactly container we want to use in our case, and what property in our document responsible for the partition key. And we have also warehouse service and customer service. Those two services are responsible for handling different use cases. So I want to create a customer view. I want to have an overview of products, order information. It's going to be here. Warehouse have different use cases to show overview or a summary of all the orders for today, for example. We have another project, which is Materialized View client. It's basically a change feed processor library we are using here. It's the, not the easiest way, but also not the hardest way. So there is 3 ways how you can connect the change feed. It's direct. You basically connect directly to the specific container, and you pull all the data from there. But this is the most complicated way because you have to handle everything. You have to deploy it. You have to provide, specify what database, what container, how do you access specific partition. But this way, direct way of accessing data is really a good way to go if you want to transfer all your data into another data store, for example. Or something happened, the system crashed, you want to just duplicate it, whatever. This is a second approach, is connecting to a specific collection container and just having the triggers. Having the triggers, we will react and we will receive all the events about what happened with our documents. And this is still some things we have to be done manually, we have to deploy it as well, we have to maintain it, and error handling, but all the connection under the hood, how we access partition, how we access containers, what partition, and so on. It's all under the hood managed by the library, handled. So as we can see here, I'm getting the config file, which is just Cosmos DB connection. I'm getting my database, so I have already created warehouse database on Azure. I'm also getting the container, specific container from a database. It should be either created already, or you should have it before a check, create container if not exist. Otherwise, if you would not have this check, it will just crash. It will not create it automatically if container is not there. We provide the instance name, list containers just to manage the state of our change feed processor, and we basically just starting the process. So what is happening now, we're just connecting, basically saying, this database, this container, connect and receive all the events, push it to our client, and then we can handle it in the way we want, create different customer view, warehouse view, for all the use cases. Of course, for every use case, we should have separately the logic. We should not have it like this, but demo. So this is kind of still quite a lot of code. And if you would write it nicely for production, not for a demo, it will be even more and even more complicated. But it's just to show an example of how it works and how it looks. If we will have an Azure function, we will have a trigger. This is basically the only code you will need to write. I mean, the same functionality we saw before, but much shorter, and I think a bit much more actually understandable. But the same thing is happening. So we have a database, we have a container, we subscribe, and we just receive the events. The difference is that Azure is going to manage everything for us. We don't need to worry about deployment, like publishing, all this stuff. The same logic happening, what we were doing before. We were creating customer view or warehouse view. Here I decided to make it separately. I have two different functions, warehouse view trigger and customer view trigger. In more ideal way, it will be different function apps, even like this, because you would want to have team responsible for the customer system, like part of the system, and the completely different team will manage, of course, warehouse system. So, but basically that's the only thing you need. Specify the connection to your Cosmos DB, and you have the bindings. In my case, I'm not using specific, like what kind of container or what kind of document I want to get, if it's output or input binding. I'm using the binding which will provide for me client, which is basically connection to my Cosmos DB. Why I'm doing this? Because I have a bit of, while handling the customer view, I have read operation, then I'm creating document, then I'm updating. So there's multiple operations, and with one binding, like I would not be able to do this, and I don't want to like have a lot of messy bindings on top of each other, one on top of each other, another. So I decided just to use the client here and have everything under the hood. So going to Azure now. When Elliot was running his part of a demo, we already, like, my function apps, they were already published and they were already up and running, of course, and it's already, you can see the container for the customer overview and hub monitoring. So that's basically what was created as a result of adding and processing orders in our system. So let's have a look on the customer overview. First of all, we have items. As I was saying, I used the ideal case. My ID of a document is unique, and it's the same as a customer ID. So in this case, I have one logical partition per each customer. There is different strategies for different use cases, how to partition your data, how to model your data. But in my case, I wanted just to have the cheapest operations as possible, because yeah, it's quite expensive to do the demo for on Azure as well sometimes. But without jokes, usually you will have a partition key, for example, will be the same value, but you will store multiple documents under the same partition. You will have document ID 1, 2, 3, 5, whatever, but customer ID will be the same. What it means that when you will say, get me data for the customer, like 50054, it will give you back a bunch of documents. You will be able to aggregate, do whatever, transform the data, but they all gonna be related to the same, basically, customer. The idea of having those logical partitions, basically, there is a guarantee that the data always will be on the same physical machine. It means that our operations will be cheap, much cheaper, and we will avoid cross partition querying if you want to get some data for the customer, for example. So that's how our aggregated view for the customer looks like. We have all the orders and some like order number, of course, status, articles, and the history, basically, what was happening with those orders. I have one file for the customer, and like here is fine, it's not that big, but if it will start growing, it means also the cost will change on write, because you have to also pull the document when you write, and cost will change on read. And in this case, if you see that file is really, really growing, it's better to split up and better to maybe create another materialized view for those purposes, but not to grow like a huge file that you would not be able then to transfer. So yeah, that's how the customer overview looks like. And the warehouse, the same story with the partition key. The only difference here that I will have date instead of just ID. I have a combined ID of the warehouse with a certain date, so I know what the amount of orders was successfully processed, for example, for the specific date. This use case was to install monitors in our warehouses and just display some like green numbers or red numbers that this amount of orders was processed, failed, and so on and so on, for every day, how the system is running. This file will not grow because we don't really store any information, instead only count, and I mean it will grow, but not that significantly, because how many orders you can process in one day? So there's quite limited amount, I would say. Yeah. So if your file is not bigger than 1 kilobyte, it's going to be 1 RU for the read operation. And this is the cheapest you can get. So I would say for read operations, for that kind of use cases, like simple, when there's a lot of requests, better to stick with this number. And that's basically, yeah, that's basically almost done. We will do just a couple of key takeaways. I just want to summarize what we saw before. Those like projects, like the same thing, change feed processor library, and then Azure function, which is doing the same thing. What's the difference basically? Why do we want to use this or this? How to choose? Azure function is just serverless, so we don't much less effort, much easier to build independently, and scale, of course, maintain with the change feed processor library. It's much more controllable. Yeah, we can write code, it's great, but then we have to have a headache like of maintenance, like we have to have the people that actually taking care of this, of like deployment and all the things, managing. So that's why Azure Functions kind of, in our case, was better way to go, but there are some, of course, exceptions where you can say, no, change feed processor library will be for me better fit. So Cosmos DB, as we saw, is central append-only persistent data store. Why it's great for our case? Because it's because of scalability, because of global distribution, and of course because we have it like serverless and pay as you go. It's also quite a positive moment.
And so what we would say is, if you have those heavy write workloads, then definitely look into event sourcing. It's not only for like heavy write workloads, but that's where it shines the most because of the dozen inserts. So definitely have a look at the pattern. Of course, like with everything, like it depends on your scenario. So don't just say, hey, I heard about event sourcing, I'm now going to implement event sourcing into everything. But have a good look, like, how does this fit into your architecture? Does it make sense for your workload? And so have a look at that.
Yeah, event sourcing, I think, makes sense to use for the system where it's really, really like important to have your data, like finances, healthcare, like this makes sense. But for, I don't know, some entertaining application, for example, it just doesn't make any sense. It's overhead. But you have to learn somehow. So sometimes overhead is also a good experience. Materialized views for various consumers we already saw. It's quite easy. Have an Azure function, just connect to a specific container. And every time there's change happening, we just do whatever like business logic we need. We need to create overview of the customer or warehouse, or just maybe notify some other part of the system that something happened. With Azure functions, with Materialized View, it's easy to do and very flexible.
Yeah, and finally, of course, Azure, I always see it as a big box of Lego. You have many different components in there. We showed you 5 of the different sources today, but of course there's many more. For example, Event Hubs works perfectly together with Stream Analytics. So you can just push Stream Analytics on that. You can, like these days, they even have like a no-code solution where you can just say, hey, here's my data, push it into, for example, Synapse or into a storage account. So definitely have a look at all those different sources and have a look like how can you best architect your application, your solution to make use of those different capabilities. And like really look at, okay, what makes sense for us?
Yeah, actually what you mentioned, Apache Spark was something we were looking at when I was working in a product company. Event sourcing is great. We have like a lot of events come in our system, but what if we need to have real-time calculation of data or like aggregation? Cosmos DB can do some things, but not that fast, not that efficient, and not that cheap. It's much more expensive. Apache Spark has a integration with Azure Cosmos DB, and under the hood connects nodes and can perform those real-time calculations, like basically right away. So that's what I wanted to add about the ecosystem in general. Yes, so we want to say...
Yeah, so once again, thank you to the sponsors because they make this possible. Please go have a look at them, like talk to them, thank them for being here. These kind of events cannot be done without those sponsors, so thank you to the sponsors. Of course, our event sponsors, our platinum sponsors, and our gold sponsors, they're all here, so talk to them. And of course, also, thank you for being here. So
yeah. Thanks to you for sharing again the stage with me. Thanks for listening. And I was going to click. There's our contacts. If you have any questions, comments, or I don't know, maybe you want to complain about him, service costs or whatever, that's to him. Yeah, feel free. And we will be always happy just to chat and just get connected. So thanks a lot.
Thank you. And thank you.